Dear students, greetings for the day. In the previous class, we discussed the projectile motion of a body into air. That is, we project a body into air in three ways. That is, vertical projection of the body into air. Second one is the horizontal projection of the body into air. And third one is oblique projection of the body into air. In vertical projection, a body is projected with the initial velocity at an angle theta equal to 90 degrees to the horizontal. Then the body moves in the vertically upward direction. As it moves up, its velocity is affected by the gravitational pull of the earth, and its velocity gradually decreases at the rate of 9.8 meters per second, and finally it becomes zero at certain height. So this height is known as maximum height. So when a body is projected from the earth from point A, now as the body is moving up, its velocity gradually decreases. Then its acceleration is said to be negative, and it is equal to minus g. Here final velocity is equal to 0. Now the maximum height s equal to h maximum is equal to, in this case, u square by 2g, and time taken to reach the maximum height Ta is equal to u by g, and time of descent, that is the return journey from B to A, is also equal to u by g, or 2h by root 2g, h maximum. And time of flight, total journey time, is known as time of flight. U by g, time of ascent plus time of descent, that equal to u by g plus u by g to u by g. These are the expressions in vertical motion of the body. And when the body is projected into air parallel to the horizontal direction, then theta is equal to 0. So in horizontal projection, a body travels like this. Consider a body which is projected with initial velocity from point B, which is at a height h. Then as it moves, it always travels with the same velocity u. Due to this horizontal component of velocity u cos theta angle of projection is 0, therefore cos 0 is 1, therefore u cos theta is also equal to, therefore so when the body, let the moving in the horizontal direction, let it reaches to the point C on the earth. Now here in this case, the horizontal distance traveled, expression for horizontal distance traveled is u into t, and vertical distance traveled is s equal to half gt square, since vertical velocity is 0 in this direction at b, so ut plus half at square. When the body is projected in the horizontal direction, then the path of the projectile is here nothing but it is in the form of y equal to kx square. Therefore, path of the projectile is parabola. From this expression, s equal to y equal to half g into t means here x by u. This may be written as y equal to g by 2u square into x square, which is in the form of y equal to kx square, where k is g by 2u square. So the path of the projectile is parabola in the case of horizontal projection. Now in vertical projection, third one is vertical, sorry, oblique projection. Here theta is other than degree, so 0 degrees is less than, theta is less than 90 degrees here. Therefore, when the body is projected at an angle at initial velocity u at an angle theta to the horizontal, then at the body reaches to the ground like this. Now this is horizontal range or horizontal distance traveled. This is the maximum height reached by the projectile. So maximum height reached is equal to, in this case, u square sin square theta by 2g. Time of ascent is time taken to reach from O to B. U sin theta by g. Where in this direction, vertical component of the, as u is, when u is written as horizontal and vertical components. Horizontal component is u cos theta, vertical component is u sin theta, and time of descent is also equal to same. Therefore, time of flight is equal to, in the case of oblique projection, Ta plus Td is equal to 2u sin theta by g. Now horizontal range is equal to horizontal component of velocity into time of flight. Therefore, horizontal range u square sin 2 theta by g. And maximum range is sin 90 is equal to 1, therefore theta equal to 45. Therefore maximum range or H maximum value is u square by g. These are the formulas in projectile motion. Now let us discuss the circular motion. We know that motion is three types. First one is translatory motion or linear motion of the body. That is, when the body is traveling along a straight line, then its motion is said to be linear motion or translatory motion. Second one is angular motion or circular motion. When the body rotates about a point, then its motion is said to be circular motion. So when a body rotates about a point along the circumference of the circle, then its motion is said to be circular motion or angular motion. Third one is oscillatory motion. When the body repeats its motion after certain interval of time along a straight line, then it is said to be harmonic motion or oscillatory motion. Now let us discuss the circular motion or angular motion. So when a body is moving along the circumference of the circle with radius r and center O, the line joining the body and the center of the circle is called radius or radius vector r bar. So let the body is moving along the circumference of the circle with uniform speed v. Let it reaches to the point B in time interval t. Then let the angle covered by the radius vector be d theta when it is very small or theta when it is big. So this is also known as angular displacement. So here angular displacement are simply angle. Angle covered by the radius vector. In a given time is known as angular displacement. This is angle AOB. And let us know what is meant by angular velocity. It is also a vector quantity. It has direction along the tangent. Therefore, the rate of angular displacement is known as angular velocity. of angular displacement. So angular displacement by time. Or it may be written as theta by t also, when the theta and t values are higher values. And this angle is measured in terms of radians, and angular displacement is so SI unit is radian, and the angular velocity is measured in terms of radian per second. Therefore, SI unit of angular velocity is radian per second. Now let us know what is meant by linear velocity. So when the body moves from A to B, it covers some displacement. The shortest distance between A and B is obtained by joining, like this. Let it be x in time t. So length of the arc here AB. So angle is also defined as, angular displacement is defined as the ratio of length of the arc to radius. This is another definition for angle. Length of the arc is AB, that is x by radius r. Now linear velocity. It is denoted by v bar. It is a vector. So we know that velocity is defined as the ratio of change in velocity by and time. Therefore, the rate of change of velocity, the rate of displacement is known as linear velocity. It is equal to displacement by linear displacement by time. Linear displacement by time. Therefore, here linear displacement is AB, or length of the arc, by time dt. Or simply it may be written as also sometimes dx by dt also. X or dx. Here AB is equal to x or dx. If we write the displacement dx, then it is dx or x by t. Now let us derive the relation between linear velocity and angular velocity. This angle covered for one complete revolution is equal to 2 pi radians in time taken for one oscillation time period, 2 pi by t, or it is equal to 2 pi into 1 by t. It is nothing but frequency. 1 by t is therefore 2 pi n. Therefore omega is equal to 2 pi n or 2 pi by t. So relation, let us derive expression for linear velocity. relation between linear velocity and angular velocity. So here linear velocity v bar is equal to the AB by, that is length of the arc by therefore from this expression AB length of the arc r into d theta. So we substitute the value of dx, that is r data from this formula, angle equal to length of the arc by radius, or d theta is equal to AB r dx by r. Therefore AB r dx is equal to r into d theta. Therefore r into d theta by here dt. So velocity is the rate of displacement, therefore displacement covered by time taken, that is dx or r d theta by dt, by writing this as r into d theta by dt. So this is nothing but the angular displacement covered in time t dt. Therefore angular displacement by time, it is nothing but angular velocity. Therefore linear velocity is the vector product of radius vector and angular velocity. Therefore linear velocity is written as radius into angular velocity, that is equal to r omega cos theta. This formula is useful for problems. This is the relation between V, R and omega. So consider a body which is moving along the circumference of the circle of radius r and center B O. Let the body travels with uniform speed v, which is acting along the tangent direction, and let the body travels from A to B in time t seconds or dt seconds. Then here length of the arc is AB is equal to dx is equal to speed v always acts along the tangent at a particular instant of time at that point. Along the tangent it works. Therefore here AB length of the arc is equal to dx and radius vector r. Therefore angular displacement or angle equal to d theta by d theta is equal to AB by r. And linear velocity is defined as the rate of displacement, that is linear displacement by time, that is length of the arc by time. Length of the arc is AB or dx, therefore dx by dt. This dx is written as from this expression AB or dx is equal to r into d theta. When we cross multiply, AB or dx is equal to r into d theta. We substitute the value here, AB or dx value. Then by writing separately dx by dt, r into d theta by dt, which is equal to omega bar. d theta by dt is omega bar. Therefore, linear velocity v bar is equal to r bar into omega bar. So, linear velocity is defined as the scalar product of radius vector and vector product of radius vector and angular velocity, that equal to r omega cos theta. Now, when the body is moving along the circumference of the circle of radius r, then it moving along the circumference of the circle of radius r along the circular path, then some force is acting towards the center to keep the body along the circular path. So some acceleration is working along this radius vector AO direction. So this acceleration r omega square keeps the body to move along the circumference of the circle. So when the body moves along the circumference of the circle, then the acceleration acting on the body is two types. One is linear acceleration a bar, and angular acceleration a bar is equal to r omega square or v square by r. When it moves with velocity v, uniform speed v, then angular acceleration is equal to v square by r or r omega square. So angular acceleration is change in angular velocity by time. Therefore, omega 2 minus omega 1, that is d omega by dt. So angular acceleration is also defined as, but when the it is equal to r omega square or v square by r. So this is known as a centripetal acceleration. This is also known as when the body is moving along the acceleration. This is also known as centripetal acceleration. Then so the force which keeps the body to move along the circumference of the circle, then the force acting towards the center of the circle is known as centripetal force. CPF. This is from the definition of force. Force is equal to the product of mass and acceleration. Therefore, here mass into acceleration. Mass is m, acceleration is r omega square or m into v square by r. Therefore, centripetal force is equal to CPF is equal to m square by r or mr omega square. kg radian per second square. And from the Newton's third law, to every action there is an equal and opposite reaction. When the centripetal force acting towards the center O, then at the same time in the opposite direction some centrifugal force is acting as reaction force. Therefore, here the force acting away from the center is known as centrifugal force. Centrifugal force. In magnitude, it is same as that of centripetal force. That is m r omega square or mv square by r. But direction is opposite. If f bar acts in the direction AO, then it acts in the outward the circle. Therefore, when a body moves along the circular path, it experiences centrifugal force, due to which the body skids. Now let us know about banking of roads and railway tracks. So, when a body moves in the circular path of radius r, then when its speed exceeds certain value, then the vehicle skids in the outwards the circle direction, therefore due to centrifugal force. So to avoid this skidding, outer edge of the road is raised over the inner edge. This is called banking of roads and railway tracks. So banking is defined as the banking of roads is defined as the raising of outer edge of the road over the inner edge. To avoid skidding. Banking is two types. First one, height of banking. Second one is the angle of banking. So, when the body travels along the circular path, when it speed exceeds certain value, then there is possibility of skidding of the vehicle due to centrifugal force. So, to avoid skidding, outer edge of the road is raised over the inner edge of the road, called banking of roads. So, this is two types. Banking of roads is two types. Height of banking and angle of banking. Let us know about height of banking. Let this be road, and outer edges of the road is raised to certain height. And this is called height of banking. This data is called the angle of banking. So height of banking is the height of the outer edge of the road raised over the inner edge of the road. When compared to the horizontal direction. Therefore, here height of banking is equal to BC, that is equal to H. So here H is equal to, and it is equal to L, then opposite side by adjacent side, opposite side BC by AC, hypotenuse is sin theta. Therefore sin theta is equal to the figure H by L. So from this H is equal to L into sin theta. L is the length of the road AC, and sometimes it is taken as 2L in some figures. Length of the road is L or 2L. So height of the banking H is equal to L sin theta or 2L sin theta, depending upon the convention used. Next, angle of banking. Let us derive expression for angle of banking. So it is the angle of the outer edge of the road raised over inner edge, that is outer edge of the road makes with horizontal direction. Made with the horizontal road AB. This data or angle BAC. Now consider a body of mass m which is moving at its weight vertically acts. Now the normal reaction R bar acts in this direction. Now the component here mg cos theta is balanced by R bar. Now this R bar can be resolved into two perpendicular components, one along the mg, this is R bar cos theta, and this is R bar sin theta. which provides the necessary centripetal force towards the center of the circular path. So the circular path has some center and it acts towards that center r bar sin theta, which provides the necessary center. And centrifugal force acting in this direction, which is balanced by, so r sin theta is balanced by centrifugal force mv square by r. So here provides the necessary centripetal force. Therefore, r bar sin theta is equal to mv square by r, and r cos theta is balanced by its weight of the body. Dividing these two equations, we get mm gets cancelled, sin theta by cos theta, rr gets cancelled, tan theta is equal to v square by rg, or theta is equal to tan inverse v square by rg. So this is the expression for angle of banking, theta. So when a body on the traveling along the circular path of radius r, then as it is traveling on the circular path, it experiences centrifugal force. Which is equal to mv square by r. So r sin theta is also equal to mv square by r. So here r sin theta provides the necessary centripetal force. R sin theta is equal to mv square by. From this figure, r cos theta balances its weight. Therefore, r cos theta is equal to mg. So divide equation 1 with 2, r gets cancelled, gets cancelled right side. Therefore, v square by r into g. R sin theta by cos theta is equal to tan theta, and v square by r into g, v square by rg, or theta equal to tan inverse v square by rg. If we know the values of velocity of the vehicle, radius of the curved path, then we shall calculate the angle of banking, theta. So in the circular motion, we derived the expression for linear velocity, that is the relation between linear velocity and angular velocity omega. So the relation between v bar and w bar is v bar is equal to r bar into w bar, or r bar omega bar, that equal to r omega cos theta. And we know the definitions of centripetal acceleration. The acceleration which is acting towards the center of the circle via direction is known as centripetal acceleration v square by r, or r omega square. And centrifugal force, the force acting towards the center of the circle in bx direction, then, and the force acting towards the center of the circle, that is in VA direction, is known as centripetal force. The force acting towards the center of the circle is called centripetal force, and the acceleration acting towards the center of the circle is called centripetal acceleration. It is equal to v square by r, or r omega square. And to avoid skidding, vehicles vehicle skidding is avoided by banking of roads and railway tracks. So when we raise the outer edge of the road certain height over the inner edge A, that is when compared to AB, then it is called height of banking, BC. H equal to L sin theta, or BC is called height of banking. And this angle BAC is called angle of banking. So when we consider the vehicle moving with uniform speed V along the circular path of radius R, then here R sin theta provides the necessary centripetal force, which is balanced by centrifugal force mv square by R, and normal reaction R bar, its another component R cos theta balances the weight of the body mg. Then R cos theta is equal to mg, R sin theta is equal to mv square by R. Therefore, by dividing these two equations, we get R gets cancelled, sin theta by tan cos theta is equal to tan theta is equal to v square by R into g, mm gets cancelled. Therefore, theta equal to tan inverse v square by rg. So this is the expression for angle of banking. In the next class, we shall do some problems on oblique projection and horizontal projection, and on this circular motion formula v equal to r omega and theta equal to tan inverse v square by rg. If you have any doubt, please contact me.